Hello everybody, I wanted to take a few moments to do examples of the difference quotient. So it's defined as f of x plus h minus f of x all over h, provided h is not equal to 0. So the purpose of the difference quotient can be really seen graphically, and suppose we have some function, and what we're interested in is the rate of change between x and x plus h. So the rate of change is the slope. We also call this the secant, the secant line, and so it's going to be the slope between these 2 points. So the output for x is f of x, and the image for x plus h is f of x plus h. And the way that we compute slope is it's the change of y over the change of x, so the change in the vertical distance. And so this change is going to be f of x plus h minus f of x. And then the change in the horizontal distance is x plus h minus x. And that's how you can tell that in the denominator it's h. So the difference quotient allows us to find the slope between x and x plus h. Alright, so let's suppose we had f of x is 2x minus 5. Let's find the difference quotient for this. And the way that we do that is we plug in x plus h in for x, and then subtract that from 2x minus 5. So we'll have 2 times x plus h minus our 5 minus our function. So we need to remember to subtract the whole thing, all divided by h. We'll distribute the 2 with 2x plus 2h minus 5. Distribute the negative, and all over h. We'll see that the 2x and the negative 2x goes to 0, negative 5 and plus 5 go to 0, and we will end up with 2h over h, which is really 2. And so if we go back and look at our picture, we had said that the difference quotient tells us the rate of change between x and x plus h, which is another way of just looking at the slope of a curve. When we have a linear function, we can see that the slope of this linear line is going to be 2. So when we do find this difference quotient, we shouldn't be surprised that the slope, or the rate of change between x and x plus h, is still 2. Alright, let's look at a different example. So suppose we have f of x equals 3x squared minus 4x plus 6. And let's find the difference quotient. So f of x plus h minus f of x, it looks like absolute value, minus f of x all over h. This will equal 3 times x plus h squared. Still plugging in x plus h, so we'll have minus 4 times x plus h plus 6 minus the whole function. So we're subtracting the whole thing. all over h. Okay, so now what we want to do is we're going to want to multiply this out, distribute the 3, distribute -4, and distribute the -1 over here, and see what cancels. Alright, so we'll have 3 times x squared plus 2xh plus h squared minus 4x minus 4h plus 6 minus 3x squared plus 4x. This pen's not working out well. Minus 6. And this part right here is a minus 3. Okay, so then this is all over h. Now I'll distribute the 3. So we'll have 3x squared plus 6xh plus 3h squared Okay, let me just check my work here. Alright, then minus 4x minus 4h plus 6 minus 3x squared plus 4x minus 6. All over h. Okay, so now what we'll do is look to see what cancels. There's the 3x squared and negative 3x squared, negative 4x and 4x, plus 6 and minus 6. And that looks like about it. We'll then be left with 6h plus 3h squared minus 4h all over h. This is a 2. Okay, so in the numerator, what we can do is factor out an h, or essentially what I can also do is divide every term by h. So then this will leave me with 6x plus 3h minus 4. And that's going to be my answer. So hopefully this helps, and again, this is going to be a useful topic that you'll see in Calc 1. Oh, and another remark is, when you are doing these problems, in the end, your h should cancel. So that in the numerator, you should end up with a term, a polynomial, so that all the h's on top cancel with the h in the denominator. If I had some other term up here that did not cancel the h, it doesn't mean you just forget about it. I would go back up here and check your work and make sure everything's okay. Alright, so I'll see you later, class.